We have Christopher Duston, and he is presenting the Jupiter, Saturn, and the Moon, Observation, History, and Mythology. And tune in. We'll be looking at the Moon and the planets Jupiter and Saturn and talking about how our knowledge of them has changed throughout history. We will observe them with the telescope and discuss how their early mythological significance has changed into our modern scientific understanding. And so Professor Duston is a faculty member here at Merrimack College in the physics department, and he is the director of the Mendel Observatory. His research interests include Einstein's general theory of relativity, as well as the life cycle and evolution of stars. He works with the undergraduate students to perform observations of supernovae, variable stars, active galaxies, and asteroids. So we are in for a treat tonight. I hope you sit back and enjoy. It's all yours, Chris.
Yeah, thanks, Anne. So welcome everyone to the Mendel Observatory. As Anne said, my name is Chris Duston. I'm on the faculty here, and I'm the director of the observatory. You can see the image that you're seeing right now is sort of overly bright and sort of distorted. That's because I'm actually inside the observatory. I have it slit open. There's noise coming from outside. And so it's just a lot of stuff is going on. So sorry if the image of my face isn't great. I am showing also on the screen 2 images of the planet Jupiter. Before we get too much into that, I thought I just want to introduce a little bit more about the observatory and maybe introduce you to our actual telescope, which is going to mean me moving this camera a little bit. So there is our telescope, that big silver thing right up there. So this telescope is the largest telescope north of Boston. It's designed based on the Hubble Space Telescope. It's the same design as the Hubble Space Telescope. It was donated to the college maybe 20 years ago and now lives on the top of the Palmisano building. We use the telescope for any number of things, from doing outreach events like this to doing research to getting students up here and working. So it's a great place to just get students interested in STEM and also do some real science as well. And I'll mention at the end of the talk, we have some interesting science stuff coming up, not related to Jupiter and Saturn, but I'll mention it when I get to the end. The other thing I wanted to mention before talking about what we're looking at is we have some information on the webpage of the observatory, which tells you some stuff about the sky. So I just wanted to jump over to there and show you that a little bit. So here's the Mendel webpage observatory, and it tells us about the college and about the telescope a little bit. You can see there's some pictures of us, some working with some students, that kind of stuff. Normally, I guess I'll just plug, normally we are open every Wednesday to the public, provided that the skies are clear. Of course, the COVID pandemic has kind of messed that up a little bit. We are hoping to be able to be reopened to the public in the spring. At the moment, we are closed, but once the spring comes around, please go back to this website and check it out. It's easy to find, like Mendel Observatory will get you there, Merrimack Observatory will get you there. But what I wanted to point out is that this cool little chart here. So, of course, weather is super important in astronomy, right? If it's cloudy, astronomy can't be done. We can occasionally see the moon through the clouds, but that's about it. So it's really critical for us to be able to predict what the cloud cover is going to be and what the other aspects of the sky are going to be at any given moment, so we know whether it's worthwhile to go up and use the telescope. So here's a cool little chart which tells you ahead of time whether it's going to be clear outside, not just from the perspective of humans. We want it to be sunny, we want it to be warm, right? But that's not what astronomers want, right? Sun is good because sun means no clouds, but actually warm is bad for astronomy. Really, you want the night to be as cold and as still as possible, and that's what this chart tells us. So what's actually great, and what's great for working with students, is that there's a summary here. This summary, it's just red is good, red is bad, green is good, just like if you're driving in a car. So for instance, if you look right now, we are at right in between, if we are generated at the right time, 6:30, we're right in between red and orange. So the prediction right now is actually don't do astronomy. Now, you can actually look out and see that there are some stars. So the prediction appears to be only about half right, and that's about what you get with this astronomical predictions. But it splits up the cloud cover in a very interesting way. So it tells you the total cloud cover here, the low clouds, the medium clouds, the high clouds. If you're into weather, this is a really fascinating breakdown of what's going on with the weather. Visibility, this is actually really important for astronomy. It's basically a statement of the fog. You want the visibility to be exceptionally good in order to see the stars. And actually, that's what we're benefiting from tonight, is that visibility is actually fantastic. It's just that there's a few in this case, high clouds. And the high clouds will sort of diminish while the medium clouds come in, and it will get a little better, closer to 7. But in any case, that's what this chart is showing us. And so I use this to predict when I can do various kinds of astronomical observations. You know, like on Friday, and I'm hoping to be able to open the observatory, but you can see on Friday it's getting red into orange, so maybe it's not going to work. So anyway, just wanted to show you that we have this cool little way of talking about weather and astronomy, because it's not really the same as like looking at the Weather Channel. Really, we need a more detailed analysis of the weather that really focuses on what you can do with astronomy. So I'm going to jump back over to the telescope, but I do want to say, please, any questions you have while I'm getting into this, please drop into the chat. I can't currently see the chat. I think maybe that is just going to be a permanent thing. So maybe what I'll do is I'll go through talking about Jupiter a little bit, and then I'll maybe ask someone who's maybe looking at the chat, or I'll figure out how to look at the chat to get some questions, because I would like to have the opportunity to answer any kind of questions you have. So I think with that, I will switch back over.
And I will let you know if there are any questions posted in the chat, okay?
Okay, great, Anne. Yeah, and feel free to interrupt me as well if there's something there, you know.
Excellent, all right.
Okay, so my idea for this night was to take these three bright objects, the moon, Saturn, and Jupiter, and sort of do a history and mythology, sort of the prehistory of before we sort of analyze them carefully as scientists, through the development of the telescope, because the development of the telescope is one of the biggest milestones in astronomy. That's how we've sort of really figured out what the planets are, into spacecraft. So now we study these planets by sending probes to them and getting really great images of them. So I thought I'd do the whole gamut, sort of talk about the history of our knowledge, then like how our knowledge evolved with the evolution of the telescope, and then show you some spacecraft pictures, right? Great pictures from Voyager and Cassini and all these spacecraft who are up there right now studying. Of course, you know, this is a very technical thing. I have this telescope hooked up to two different cameras, and the sky is currently moving. You can see Jupiter is getting a little bit dimmer. That's because I didn't move the slit. There's a slit in the dome, which is opening up to this air. So I need to move the slit a little bit to make sure that I can still see Jupiter. Okay. And I may need to make some adjustments to the instruments as we go. You can see Jupiter is still getting a little bit dim. That is baby clouds. So let me make some real quick adjustments to it and see if I can get slightly better images, and then I'll continue talking about what I would like to talk about. I'll try to talk about like what I'm doing. So I have there's actually two different telescopes up here. The one I'm on now is our smaller telescope, and my hope was that using this smaller telescope, I could, show you the moons of Jupiter. So what I'm doing is I'm overexposing the planet. The planet of Jupiter is that little dot, the actual dot that you see there. And you can see there's three smaller dots around it. Those are actually the moons of Jupiter. On any given night, you can see between, well, sometimes 0, but certainly sometimes up to 4 moons. Those are the moons that Galileo discovered when he first looked at Jupiter through the telescope. And one of them is behind Jupiter. That's why we only see 3, is because there's 4 out there, but one of them is behind the planet. I'm now going to go to the bigger telescope and try to get this image a little bit better. I suspect you can't hear me, so I'm not going to talk much while I'm up here.
Okay, can you hear me while I'm reading a question?
I can hear you if you want to.
Okay. So when the image of Jupiter is a bit dimmer, it looks like I can see a bit more stripes. Do you play with the exposure or slit to see different features?
Yes, that's exactly what I'm trying to do, is that, you know, I can overexpose on the right-hand side and pick up the very dim moons. If I get the tuning of the exposure times correct on the right-hand side, that's the bigger telescope. That's this massive silver telescope up here. Then you should be able to see stripes. And you can see that I kind of got it tuned a little bit. I don't know that I'm going to get it much better than that right now. There's a fidelity issue because that's a phone camera. It's a cell phone camera that I just stuck on the telescope. It's being transmitted to the computer, which is then being sent across the internet. So we're losing some quality as it goes. In addition, you can see it's just bouncing all over the place. When you build a telescope on top of a building, it's very convenient, but it doesn't lend itself to images being stable. So that's what's going on there. But yes, those lines you see on Jupiter that I tried to get into focus, that I can, like, you can sort of see them popping in and out. Those are the cloud bands. There should be red bands and white bands, and the cloud layers are moving against each other. So the red bands are going one direction, the white bands are going the other direction. Jupiter is a stormy, chaotic place. You might know about the Great Red Spot, which is a weather system on Jupiter. On nice nights, you can see the Great Red Spot, but it's unusual from Merrimack because of our position, because of the light pollution, because of all the stuff that's going on for us to actually be able to see the Great Red Spot. So I'm going to leave the images like this for the moment, I think. Talk a little bit about, and Jupiter is vanishing. And it's back. So you can see just, that's probably a cloud passing in front of the camera, you know. Okay, so why don't I just get into talking a little bit about the history of our understanding of Jupiter. So, you know, humans have been looking at Jupiter for the entire history of humanity. And before even we consider like Homo sapiens, right? Jupiter is a bright object. If you go outside right now and you look kind of southeast, you'll see a bright star about 45 degrees. That's Jupiter, right? So I can see it with my naked eye. Our ancestors could see it with their naked eyes. We've been staring at Jupiter for our entire history, right? And so it's a big part of not only early civilization, but mythology until we got to a telescope to actually look at it. So some of the stuff that Jupiter was used for in ancient times was as a symbol of the spirituality of gods, right? I mean, Jupiter is named after the Roman god, the sort of leader Roman god, Jupiter, who's equivalent to Zeus, which I'm more familiar with, right? I think we're all probably more familiar with Zeus and the Greek gods, but he was the head god, right? And so they knew that Jupiter was this super important planet because they could see it all the time. They knew that it orbited the sun with a period of 12 years. Now, of course, there's some argument about did the early planets orbit the sun or did they orbit the Earth? Now we know they orbited the sun, but at the time, all they saw was this bright object going around the Earth or whatever, the sky, every 12 years. And so early humans knew about Jupiter. We've known about Jupiter for a very long time. Of course, the word planet means wandering star. So that's how they distinguished it from the stars, is that the stars are rigid, basically fixed, never moving. But Jupiter, of course, moves around relative to the stars, and we've known this forever. So the other thing that's sort of interesting about the sort of mythology of Jupiter is that it's possible that it might have influenced the Chinese zodiac. So many of us know the Chinese zodiac as the animals that make up each year in the 12-year cycle of the Chinese zodiac. The rat, the rooster, the snake, those kind of animals. We all sort of know which zodiac we are and stuff like that. There are some references that say that the 12 years in the Chinese zodiac calendar actually references the 12-year cycle of Jupiter as it moves through the constellations. Now, not every reference I've seen says that's true about Chinese astrology, so I'm not sure, but I definitely have seen that reference as a possible reason why there are 12 cycles in the Chinese year, in the Chinese zodiac. So I'm not sure if that's totally true, but what is definitely true is that when you think about the heavenly bodies and you think about what are the most important ones, the sun and the moon are obviously the most important, but Jupiter is the next brightest and had the next largest impact on sort of society, culture, spirituality throughout the centuries. And so that's sort of how you think about Jupiter, is that it's this massively important object, you know, not like the moon, but it has been there for the entire history of human civilization and even before, right? So that's sort of the prehistory of Jupiter. The modern understanding of Jupiter started when Galileo, who basically invented the telescope. Now, who had the real first telescope? It's not really clear, but Galileo was there, right? One of the earliest telescopes, he looked up at Jupiter and he basically saw what you are seeing on the screen. Now, Galileo's telescope was much smaller. It was much less powerful, but it was relatively easy to see that Jupiter was being orbited by 4 smaller moons. This was significant at the time because it was thought at the time that everything orbited around the Earth. Every single object in the entire universe, solar system, orbited around the Earth. That is the geocentric model of the universe. Of course, once Galileo discovered that there are things that do not orbit around the Earth, there are things that orbit around Jupiter, that was a sort of nail in the coffin for the geocentric models, because it wasn't true that every single thing went around the Earth. Some things went around Jupiter. So once that sort of came to light, then people started thinking about maybe a heliocentric model of the universe where at least the solar system goes around the sun is more viable. And that led to our real understanding of the modern solar system. So that was sort of the beginning of the study of Jupiter with the telescope. I mentioned the Great Red Spot. I have some pictures of the Great Red Spot, which I'll show you in a moment. That was discovered in the sort of mid-1600s by Robert Hooke. And, you know, people argue about who discovered the Great Red Spot and stuff like that. It's a massive storm on Jupiter, but what's fascinating about the Great Red Spot is it has basically been continuously observed since 1650 or something. So for the past 300 years, we've been watching a storm on Jupiter just rage. No ending, no beginning. It just has been there and is still there. Now, it's true that like when you talk about astronomy from the 1700s, not like everyone had a telescope and could go out and check to see, ooh, is the Great Red Spot still there tonight, right? So there were gaps in the understanding of the Great Red Spot, but basically we believe that for the past 300 years, it's been a storm raging constantly on Jupiter, and that's borne out through every observation that we've ever come across. So after the 4 Galilean moons and the discovery of the Great Red Spot, sort of research on Jupiter was kind of stagnant because we couldn't get up there. By the time the turn of the century, 1900, 1905, the telescopes became more advanced and we were able to see more moons. I think I'll just click over to my image and try to look a little bit to see. So you can only see 3 moons. One of them is behind Jupiter. Actually, if you give me 1 minute, I can tell you what the moons are, maybe. One thing that's great about our telescope, it's completely controlled by a computer. And so I can just like look at the computer and tell you, oh, this is interesting. So maybe the 2 moons are on top of each other. So Europa, Io, Callisto, and Ganymede. Let me flip back over. So this moon down here is called Europa. This moon over here is Callisto. And actually there's a moon right here, which is either Io or Ganymede, and I can't really tell on the image. They're really close to each other. So we got Europa here, Callisto over here, and this is either Io or Ganymede. I can't actually tell. So Jupiter has a lot more moons than what we're seeing. Even these 3 or 4, given the one that's behind the planet, it has 79 moons, I think, some obnoxiously large number. Most of them are just rocks. Some of them are relatively big, but most of them are relatively small. And so it took a long time to discover any more of those moons. So for a long time, our understanding of Jupiter was Great Red Spot, some cloud cover, 4 moons, before we started discovering that Jupiter actually had many, many, many moons. And I can see, Anne, you unmuted yourself. Is there a question?
Yes. Yes. Why are the moons named the things that they are?
Oh, no. So I can't tell you, sorry. But I can say that astronomers pick certain classifications of things to name celestial objects after. So the planets are all named after Roman gods: Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune. Pluto, now of course Pluto was named that before we knew it wasn't a real planet. It's a dwarf planet. It got the name Pluto, which is one of the Greek gods. So Io, Europa, Ganymede, Callisto are some classification of something, which I don't know. Sorry. Actually, if anybody in the chat wants to answer that, I bet there's somebody out there who actually does know why we have that name for them. And my guess is if you find out why those 4 moons are named that way, the answer is all of Jupiter's moons are named for that classification of things. A certain set of gods. Sometimes think, like on the moon, craters are named after mathematicians. So it's a classification of things, and that's how we name them. And I can see someone else's answer. I can hope that person has the answer to where the names come from.
It says they're named in Greek mythology. Sorry, I couldn't see the whole thing.
There you go, lovely. So I bet that if you looked at the other moons of Jupiter, they would also be named from Greek myths. So I think that's basically the story of Jupiter through the telescope. And of course, when I say through the telescope, I'm talking about pre-Hubble, right? Hubble is a pretty amazing telescope. I'm talking about telescopes like the one you're looking at here before you took a telescope and put it into space. So now what I'd like to do is just show you a few pictures of what Jupiter looks like through the spacecraft that we have sent to Jupiter. So if you give me a minute to switch screens. I suspect that you are seeing my presentation with like all the other slides. Sorry, this is good enough for the moment, I think. So the first spacecraft to visit Jupiter was Pioneer in 1973. Pioneer was exactly what it sounds like, a pioneering spacecraft. They wanted to get something out there as quickly as possible. They built Pioneer. The cameras on Pioneer are not at the highest level, the highest quality at the time, but they just wanted to get a probe out to Jupiter because once we got to the moon, the next thing is to get out to the outer planet. So here's a picture of Jupiter once you get up close to it. Here as well, there's that great red spot. Interestingly, the Great Red Spot has been shrinking over the past 30, 40 years. And so this is one of the bigger images of it. But after we get some detail of the Great Red Spot, the story gets a little bit more complicated. It's shrinking. So for the moment, notice that there's a giant red spot there. You can see there's other kind of storm-like activity on Jupiter, including other colors. whites, reds. Jupiter is mostly hydrogen and helium and a few other elements. The other elements are mostly what give it its color. It has cloud cover, all kinds of stuff. I'll go to the Voyager images next. I love perspective in these images, right? So fine, like you go to Hollywood, you watch a movie, you see a planet, it's like, cool, great, whatever. But the little details that you get when you look at real life images are like this. So that's a shadow of a moon on Jupiter. So the moon is getting in between the sun and Jupiter and creating that shadow. That's the same thing that happens with solar eclipses on Earth. But of course, I mean, actually that's what solar eclipses look like. They look like a little dot that travels over the surface of the Earth, and when the moon is in your way, it blocks the light from the sun. So I just love those kind of little details that like you really only get when you see a real actual image of the planet. So 2 images from Pioneer. Let's go to Voyager.
So while you're doing that, just 1 second. So we have 2 questions. The first one is, if this is the largest, is this the largest telescope north of Boston, include all of Canada?
Very tricky. I think that they've installed a new one at the University of Toronto, which might be bigger. I haven't visited, so I'm not quite sure about that.
Okay, and then why is the red spot shrinking? And that's from Sarah. And I wanted to give Mia credit for saying that the moons were named in Greek mythology.
Yes,
So
great.
anyway,
Yes,
but Sarah is wondering, why is the red spot shrinking?
Well, basically, it's shrinking for the same reason that storms on Earth shrink, right? So when you get a hurricane that starts in the Atlantic Ocean and travels up the East Coast, things change as the storm evolves about the weather on the planet, and it loses energy as it travels, and it eventually dissipates. So, in some sense, we can't say exactly what is happening to the great red spot on Jupiter, but we can see evolution. So for instance, if you go back and forth between the Pioneer image and this image, the red spot is basically by itself. It is surrounded by this white band, but there are not many other storms attached to it. In this image from a few years later, not only is the band not white where the great red spot is, but it's associated with all these other storms. And the most modern pictures that we get of the great red spot, we can actually see little storms spiraling off behind the great red spot. So we can't say why it's dissipating, but we can say that it is losing energy via other storm-like activities, sort of being peeled off it in various ways. And by shrinking, we also don't know necessarily that it's getting weaker. Getting smaller is not necessarily the same as getting weaker on a planet where you have these winds that are traveling at hundreds of kilometers an hour sometimes. So in some sense, we don't know, but in another sense, we have some explanation that the storm is being redirected to other storms in the area, which I hope is sufficient. I'm sorry. So we got some other Voyager images up here. Here's a more detailed image of Voyager, of the planet Voyager. Some moon down there. I don't know which moon that is. One thing that's great about the Voyager images is that we discovered rings around Jupiter. So here's this little baby ring. What you had to do is obscure the planet's disk to see this little baby ring. But Jupiter has rings just like Saturn has rings. They're just really, really tiny and faint.
See them? Wow. So, okay, Chris, we have a question from Emily. It says, why would a storm last 300 years on Jupiter? And why are there storms in the first place?
Well, so again, why are there storms in the first place is kind of the same answer as why we have storms on Earth. But basically what's happening on Jupiter is the layers of clouds. Jupiter is spinning so fast that the storms are being stretched out, so that those clouds that are wrapping around the planet, those are basically the single circular storms on Earth that are being wrapped around the planet over and over and over because the planet is spinning so quickly. So what happens is these clouds, so like the white clouds and the red clouds, so like these clouds and those clouds are moving in different directions. That connection between them starts a little circulation in some places. So why the great red spot started, we don't really know. It's the same reason why sometimes storms start on Earth, but they start in between these little areas because the clouds are pushing it against each other and causing circulation, which I think was the thing you asked. Can't remember. Correct me if I missed any of that. I'll just say the last thing that Voyager gave us was in-depth pictures of the moons of Jupiter. So this is Io. Io is not the only interesting moon. I just wanted to show one because it shows a volcano. So like we don't really see a lot of volcanic activity out in the solar system. Now that we've looked around, we see a bit more, but it's relatively rare. So Io is volcanic and it is spewing sulfur dioxide into the atmosphere around Jupiter. What's interesting about Io is that it's not like we have lava flows on Earth and it spews into the atmosphere and dust settles back onto the ground. Io is shooting sulfur dioxide into space, right? Io is not strong enough to hold on to the stuff that it's shooting out into space. So basically it's just creating these like massive clouds of sulfur dioxide that like travel around Jupiter with Io. So just wanted to point out that our understanding of this, of the system around Jupiter changed a lot when Voyager showed up there. And the last sort of most recent images from Jupiter come from Galileo and Juno. A big thing that NASA likes to do is to name famous spacecrafts after famous astronomers. So Galileo is a very famous astronomer who, like we've talked about, discovered with Jupiter. So they named a satellite that they sent to Jupiter after Galileo. It orbited in 1995. Juno got there in 2016. I think Juno is still operational. Galileo is not. They finished the Galileo mission by crashing Galileo into Jupiter because they wanted to see what would happen when they crashed it into Jupiter. Because that's what NASA does. It's great, right? Can't use a satellite anymore, crash it into something. So we just get basically very, very detailed images of Jupiter. See, the Great Red Spot is a little smaller than it was in the original images. You can see it's you know, when I say it's losing energy to the nearby storms, it's these guys, these little storms that have been created, or we think have been created more recently and are now spiraling off to do their own thing. You get another, you know, of course, I'm picking all the images with the eclipse, with the shadow of the moons, because I get a kick out of them so much. But anyway, there's one there. Now we got all these littler, smaller storms everywhere. You can see this is a Juno image. There's structure in the cloud. It just looks like a roiling, boiling gas sort of liquid. I mean, it's a pretty incredible place. And then I wanted to show a picture of one last moon, which is Europa. The thing that's great about Europa is see all these like cracks and tracks and stuff. Europa is an ocean world covered with a sheet of ice. So those are cracks in the ice of the surface of Europa. So, and the water on Europa, there's an ocean water underneath this surface of ice. It's like 100 kilometers thick. It's a massive amount of water. I was talking about this with my students earlier today. If somebody told me I had to pick a place in the universe where there could be life, I would say Europa. You can't have that much liquid water without a random chance of life. And people are thinking about that. People are thinking about sending probes to Europa to look for life. And you have any?
Yes, I do. So Arlington's wondering, is there water on Jupiter?
So in a sense, yes, because floating in the clouds of Jupiter, there are water molecules in the same way that floating in our atmosphere, there are water molecules. But Jupiter does not have a surface. Jupiter is basically a gaseous planet all the way down to an iron core. So it doesn't have water in the sense of like rivers and lakes like we do on Earth. Is that good? I thought there were.
Nope.
Okay, cool. So basically, that's what I had to do to talk about with Jupiter. Let's jump back to the other window and just try to get one more look at the planet. I think it is getting dimmer. That is probably because the sky is moving, and I haven't moved the slit in a bit.
Chris, can I ask you one more question?
Please.
Okay, so how big is the Great Red Spot related to the size of Earth?
Fantastic question. Kind of the only reason I know that is I did an activity in class on that today. It's between 2 and 3, maybe 4 times, depending on how you measure where the edge of the Great Red Spot is, because it's red. If you look carefully, it's red, and then it kind of drifts to be orangey, and then it kind of becomes white. So it kind of depends how you pick it. 2 sizes of Earth is kind of the approximate size of the Great Red Spot. And what's interesting, the calculation we did in class today, is that you know, how strong are the winds in the Great Red Spot? If the storm is twice as big as the entire Earth, that's like 100 times the size of a storm on Earth, right? No, actually the winds in the Great Red Spot are only 3 to 5 times greater than a storm on Earth. So obviously very dramatic, but not 100 times more powerful than a storm on Earth.
Okay, so now I think Sarah's daughter, Lillian, has another question for you. How does the iron core stay in the gases of Jupiter?
Awesome. Gravity, right? So when you have gravity, the Earth's gravity holds us onto the Earth. The reason that's happening is because there is more mass in the center of the Earth than the outside of Earth. That's why I don't get sucked off to the moon, right? Is because the Earth is holding on to me harder than the moon is pulling on me. Same thing happens in Jupiter. So the heaviest elements of Jupiter have sunk to the center and have formed this ball of iron, and that's just incredibly massive. It's huge, and so it's holding all the gas onto Jupiter. So it's not that the iron is like floating in the gas is actually sticking to the iron and making a big ball.
Okay, we have questions. Are you ready for some more?
Sure.
Okay, is the red spot moving from Allison?
It is rotating and it is spinning with the planet. So just like, you know, Earth spins every 24 hours and it takes the clouds along with it, that's what the great red spot is doing. And it's also rotating like a storm on Earth is rotating.
Okay, beautiful. And then someone else asked, how much bigger is Jupiter compared to its moons?
Ooh, so that's a good one. I have to do it in steps because Jupiter is about 10 or 11 times the size of the Earth across. And its moons are less than half the size of the Earth. The biggest ones are about, so the biggest moon is Ganymede, and that's also the biggest moon in this whole solar system. And I think that's about half the size of Earth. So I think you have to say that the moons of Jupiter are about 20 times smaller than the planet in size across. In terms of mass, Jupiter is billions of times more massive than its moons.
Cool. All right, that looks like that's all for the moment.
Okay, so I have some cloud problems.
Oh,
But what I'm going to do is, I think that the images are getting dim because of the clouds. But what I'm going to do is try to turn to look at the planet Saturn. And so you're just going to have to give me a few minutes to make that happen. I'll try to show you what it looks like when the telescope actually moves. Yeah, you can see it in the upper screen if I do it right. Hold on. Like I said, the having a computer hooked up to the telescope is fantastic because I can just tell it to go somewhere and be pretty confident it is just going to zoom over there. Yeah, so you can see it just moving, just saying, oh, okay, you want me to go to Saturn? Cool, I can do that. Doop, I'm now pointed to Saturn. Now, of course, I have to also move the telescope slit. Now it's dark, right? Because I'm pointed at the side of the building, essentially. So I've got to move the slit. And this is where it's going to take a little time for me to get this set up. Yeah, so you can see that you just barely get a little, yeah, I'll answer a question, but I just get a little barely dot of Saturn, so that's because of the cloud. I mean, so Saturn you can see with your eyes. It's a relatively dim planet, but if you know what to look for, you can see it, and I can't see it in the clouds. So I say that's a cloud cover thing. Maybe what I'll do is I'll start talking about Saturn, and then maybe it'll pop out, and I'll get to show you what it actually looks like. And did you have something you want to ask?
I do have a question from my daughter. Caroline was wondering how many Earths fit into Jupiter and how many Jupiters would fit into the sun.
So if you want to know like how many you could line up across, that's about 10 or 11 Earths
Wow.
into the sun. Now I know the Earth to sun, right? So the Earth fits into the sun a little over 100 times. So that means that there'll be about 10 Jupiters that fit in the sun if you could line them all up like this, give or take. You know, it's within a few.
That's great. Thank you.
Okay, so you can see Saturn is just barely popping out. Unfortunately, it's not on the other camera. Let me see if I can get that before I start doing my spiel. The other camera is much nicer.
I have two more questions that we're hiding, Chris. I'm sorry. Are you ready?
Yeah, sure.
Okay, so we have from Emily, why is there only one huge storm, or are there more? And then, oh, she added, and more huge ones, that is. Small ones are spinning off from the large storm.
That's too bad. Focus isn't so. No, there's really only one giant storm on Jupiter. There are a bunch of smaller storms. But I mean, of course, when I say smaller storm, I'm still talking about storms that are like half the size of Earth. So they're still quite large, but there's really only one giant storm. And I'm sorry, what was the second part of the question? We lost it again. Okay, no problem. So the image is getting pretty fuzzy here. You can see that we are indeed looking at Saturn. It's a little bit elongated. can just barely see the edges of the ring. And if you look every so often, you'll kind of get like a nice image where you can clearly see the rings, but that's basically clouds. I still can't actually see it with my eyes, which tells me that the cloud cover is pretty bad. And the only reason we're seeing it is because we have this giant telescope. So maybe just for the sake of time, I'll dive into the history of Saturn a little bit. Feel free to shout questions at me. And then hopefully when I get finished with that, we can jump back. I'll leave the images up here. So maybe if we get lucky, we might be able to see some, a little bit more detail, but at least I'll be able to give you sort of some sense of what we're supposed to be doing here. So just like Saturn, just like Jupiter, Saturn has been with us the entire history of the human race, right? I mean, we've always had an association to Saturn, which, like Jupiter, was spiritual in nature. We associated gods with Saturn. Saturn is the name of the Roman god of wealth, and the Greek one is called Cronus, and in the same way, like the Roman one got the name because we have traditionally named planets after the Roman gods. Of course, it's not as bright, so it hasn't had as big an impact on our culture that Jupiter has. But of course, we know a lot about Saturn. It just hasn't found its way into myth and culture and astrology in the same way that Jupiter has, because Jupiter is the big planet in the sky. And Saturn also has a 30-year period, so it takes Saturn 30 years to go around. So that makes it a little harder for humans to study, because that's like, approaching the lifespan of an early human, right? And so when you get things that take that long to happen, people are less good at tracking them, right? So that's sort of the prehistory of Saturn. And actually, people didn't really know much else about Saturn before the advent of the telescope, because it's a dot. For Jupiter, it was a bright dot. So we thought, it was really important, but Saturn was just a kind of dimmer dot who wandered the skies just like Jupiter did. So that's basically the story until we get to the telescope. And should I take another question? And
Yes.
you want me to see if I can see the question?
Oh, no, it's okay. Are Saturn and Jupiter the only planets with rings?
No, that's a fantastic question. So one of the major discoveries of the Voyager spacecraft in the 70s and 80s was that every gas planet has rings. Now, that's not a statement that if you went out to a different solar system and said every gas planet has to have rings, but all the gas planets have rings. So Saturn is the most substantial, but Uranus and Neptune's rings are pretty substantial. We really can't see them from Earth, but they're pretty obvious when you send a spacecraft out to look at them. And then Jupiter's rings are very, very small. So all four of the gas planets, that's Jupiter, Saturn, Uranus, and Neptune, all have rings.
Okay, and Lillian has another question. Why are the planets named Roman gods and not Greek gods?
I think you need a historian for that. I think that there's a little bit of a background in the sense that the Greeks and the Romans were not the first astronomers, right? The first astronomers were, I'm ignoring an entire half of the Earth, right? So if I don't know anything about Arabic astronomy, although Arabic astronomy was incredibly advanced, they dealt a lot more with the stars. A lot of star names are Arabic because of the significance of Arabic astronomy and mathematics. Also, China had very advanced astronomy, ignoring all that because the European sort of scientific output ended up overtaking them. That's really an unfair statement. But the earliest Western astronomers were actually Babylonians, sort of 4th century BC. And my understanding is that because the Babylonians were closer tied to the Romans, there was a longer tradition of the Roman names being used, but that's kind of only my understanding. So it's a historical thing. I think that's the best I can do there. Okay, so going on, let me talk a little bit about how the advent of the telescope, revealed things about Saturn, and most obviously it revealed the rings. So actually Galileo's telescope was not quite strong enough to check out the rings. He could see some things on the side. He actually called them Saturn's ears. I don't think he literally meant that as Saturn's ears, but just as a descriptive way of saying the planet does appear to have some stuff hanging off the side. Actually, a guy named Christian Huygens was the first person to actually discover the rings in 1650, 1660 or so. Huygens also discovered one of Saturn's moons. That's the moon Titan. Titan is a super interesting place. I will talk about it later. But one thing that's kind of interesting is it just happens that Saturn has one giant moon and a whole bunch of fairly big moons. So over the course of the 16th, 17th, and 18th century, people discovered a lot of moons around Saturn when they were not discovering them around Jupiter. Jupiter had 4 moons for a long time. Saturn had, 10 or 12 moons by the time that it was 1900 or 1910. So that's just kind of I don't think that's significant, just kind of an interesting fact. And I think that's basically what we can say about Saturn until we get to looking at spacecraft and actually going out there. We knew that Saturn had cloud bands just like Jupiter did. We knew it had a few moons before we went out there with the satellite, but that's pretty much the extent of what we knew about the planet until we sent a satellite out there to check it out. So while I'm switching to my cool pictures of Saturn from space probes, anybody have any more questions?
Not yet, but we'll keep our eye open here.
You can see that the clouds are not getting any better. They are getting worse. So let's hope for the best there. Give it a few more minutes. So again, just like Jupiter, the first spacecraft, I think you guys can see my spacecraft, Pioneer and Voyager images. Pioneer 1 and 2 and Voyager 1 and 2 were the first probes to get out to Saturn to take a look at them. So this, on the left, this is a picture of what Saturn looked like from the Pioneer spacecraft. Kind of an interesting image. There's a huge gap here in the rings. This is the Voyager spacecraft. This is kind of like when I think of what Saturn looks like, this is to me what it is. I think that huge gap is because of the angle of the sun. Saturn's rings are made of basically little ice particles, and not real little, kind of like fist-sized to like car or bus-sized, but smallish. They're very reflective. And so what happens is the light gets reflected from them and we see them with our eyes. So my assumption is this is just an angle thing and probably not a real gap in the Saturn's rings. If it was, it'd be interesting, but I think it's just a real gap. But in these two images, you can see all that great perspective that I like to talk about when I want to see like a real image. Here's a little moon. Don't know what moon it is. It's a little moon. There's one there too. There's a shadow of the planet on the rings. Like I'll show you the Cassini image, which is even more incredible. But shadow of the moon on the planet on the rings. That's why you don't see that ring there. There's the shadow of the rings on the planet in the Pioneer image. That's what that line is right there. That's not a ring. That's the sun coming down onto Saturn, being blocked by the rings, making a shadow. Just like an incredible thing. You can also see there's something up here. That could be another moon. I'm actually not sure what that is or if that's an artifact. The Pioneer spacecraft had all this stuff hanging off of it. So some of the pictures like have things in the way. Anyway, just really great to look at real images of planets.
Oh, I agree. So Allison has a question. Can people walk on Saturn's rings?
Oh, on the rings? No. So
That'd be so cool.
Yeah. So it would be great if that was true, right? Actually, we know, so before we sent probes up there, our assumption was that the rings were not solid. They were probably broken up, some kind of small things, whatever. So that's our interpretation. We have actually tested that theory. So sorry, the image there is that basically the distance between all these little objects is so far apart that you couldn't stand there. They're not solid. They're more like a gas, actually. Like when you look up and you see smoke in the sky, it's reflecting light. That's more like what Saturn's rings are. Of course, they're rotating around Saturn and making this pretty disc-like structure, but they're not solid. And actually, we've tested that because just like in the, I said that for the Galileo spacecraft, we crashed the thing into Jupiter when the battery ran out, basically. We did the same thing with the Cassini spacecraft in Saturn, but in that case, we crashed it through the rings. So we went straight through the rings, right like this, directly into the planet, and the spacecraft made it the whole way without running into any ring particles. So it's not just that you wouldn't be able to stand, but they're actually mostly space, not mostly particles.
Okay, so I have another question, and I think I might have accidentally erased a question or two. So if I don't ask your question, please post it again. I'm so sorry. But someone asked, could Saturn ever have life?
Ooh, could it ever have life? Well, it's dangerous to say that something could never have life, right? Because what we know about life is that it's dynamic. It's evolved in one way in our planet, but it could evolve in other ways in other planets. So I shouldn't say never, but because there's no liquid on Saturn, that makes it extremely difficult. And it's very cold. Life likes liquid, life likes heat. So it's very cold and there's no liquid. So I think it's very unlikely that we ever find life on Saturn. Put a pin in that. When I talk about Titan, the opposite will be true. So sort of life near Saturn is a story about, is there life on Titan, not on Saturn? So I think that I'll skip on to these next images. So after Pioneer and Voyager, we have basically had only one other spacecraft go to Saturn. I've mentioned it a few times. It's Cassini. That's the name of the, I think, Italian astronomer who studied the rings very early on. So these are what we think of as the most advanced sort of images of Saturn. Oh, I guess I want to say one more thing. Saturn is not totally circular. See, it's kind of oblate. It's like not a perfect circle. What's happening there is Saturn is spinning so fast that it's stretching itself out, which is just one of those things I love, right? It means it's a huge planet. It's like 8 times the size of Earth. It's moving so quickly that it's stretching itself out. And it's easiest to see it in this image, but you can see it in the Cassini images too. This guy's a little more stretched out than a perfect circle. So anyway, more great images of the shadow of the planet falling on the rings. Look at the shape of the structure at the top of Saturn. It's like a hexagon. That's a real thing. Like there are some pictures from Cassini of the North and South Pole. They are like these geometric shapes of clouds. A really interesting feature of the Saturnian system. You can see there's cloud bands in the same way that there are on Jupiter. The colors on Saturn are a little bit diminished. So part of that is a complicated story about the chemistry that's going on in Saturn, but part of it is simply it's colder. So there's more ice like in the atmosphere, and so the light gets blocked a little bit. So the colors are not quite as vivid as on Jupiter. So that's the planet Saturn. Let me jump in a little bit talking about the moons of Saturn, because one moon of Saturn is particularly interesting, and that's Titan. So when Voyager went to Saturn in the 70s, it discovered that there was this moon. This is a Cassini image, but this is what Voyager saw as well. A moon covered by clouds that you could not see the surface of. So a moon with an atmosphere. That is an extremely unusual set of circumstances. The number of planets that have atmospheres in the solar system is very small. So when you're talking about rocky planets, it's basically Venus and Earth. Mars has a little atmosphere. You might know about that. It does have a permanent atmosphere, but it's very, very thin. Basically, no other moons in the entire solar system have a substantial atmosphere except for Titan. Titan's atmosphere is massive. So one of the things that NASA really wanted to do when it went back to the Saturnian system is to check out Titan, to try to get down to the surface of Titan, see what it looked like down there. So first, crazy image. This is Titan in front of Saturn. That's not a superimposed image. That's what Cassini saw when it like looked out the window and like saw a picture of Titan in front of Saturn. Crazy. The first thing that Cassini did is it took an image of Titan in the visual band, meaning what we see, and the infrared band, which is what redder than our eyes can see. And you can see that there's actually land masses underneath the clouds of Titan. So there's some exciting stuff going on underneath there. And let me just make sure that I got my image. Yeah, so
I have one quick question here.
Please, yes.
What is the core of Saturn made of?
Yeah, good question. So it's the same basic thing that's going on with Jupiter. It's cloudy on the outside, gaseous on the inside, and then solid metal on the very core of it. And that's basically true for Jupiter and Saturn. They're made of about the same stuff. Now, there's a little bit different chemistry. Like, Saturn has a little bit more ammonia and methane. Jupiter has a little bit more water, but they're very similar in terms of their composition. So I didn't stick an image on this for Titan because I thought I wasn't going to have time, and maybe I actually don't. But let's just talk about it a little bit. They sent a probe down to Titan in great NASA fashion. They just crashed a probe into it. They couldn't figure out how to get off the planet, so they're like, well, let's at least get there. The probe was called Huygens, named after the astronomer who discovered Titan. And it turns out that Titan is very much like a cloudy Mars in some way. So there's a lot thicker atmosphere. There's a lot more substantial weather, but it's not water. It's called hydrocarbons. So hydrocarbons are a complicated kind of chemistry. For instance, methane, butane, propane, these are all examples of hydrocarbons. And so basically what Titan is it's a world with its atmosphere made of methane, and it actually has liquid methane lakes. So there are lakes and rivers on the surface of Titan. So the question about life on Saturn, probably not likely. There's no liquid and it's very cold. Titan is cold, but there is liquid. Like methane, propane can exist in its liquid form on Titan. So I also think that, and people are thinking about this as a possible source of life in the solar system. Really, Titan is another great example of the place we should look for as life, as well as Europa was around Jupiter. So last image I have for Cassini is, again, just me appreciating the presence of these probes. So this is, again, a real image, not superimposed. So that actually means that the scales in this image are all completely wrong because it just happened that Cassini was near one of the moons of Saturn and not the others. So here's just a family tree of Saturn. So this is a little moon called Janus. This is a littler moon called Pandora. Pandora is like right inside the ring of Saturn, actually. There's Enceladus, which is a whole nother interesting story about volcanoes and geysers. Mimas is right here, and Rhea is right here. And actually, Rhea is blocking the image of Saturn. So what's great is, Cassini just took this picture when it was near Rhea. Just happened to be there, so it was the closest thing. Rhea is actually a pretty small moon, kind of just looks like a big cratered rock. So again, just a real interesting aspect of seeing the Saturnian sort of family as Cassini saw it. Okay, so let me take a quick jump over to the telescope to see what's going on there. Oof, does not look good. So let me see if I can get some adjustments. Oh, it looks very, very cloudy up there.
3D prices.
Yeah, kind of move it a little bit, but I think that might be it.
So we have some questions, Chris. Can you answer them?
Let's do some questions because I don't think, and I also cannot see the moon. I will try to get the moon if we can, but I think questions might be a better idea. So please, yes.
Okay, so Mia said that Rhea was Saturn's wife in Roman mythology.
Oh, cool. Great.
Yes. All right. And then Allison is wondering, how big is Titan?
How big is Titan? So Ganymede is the biggest moon in the solar system. That's about half the size of Earth. So Titan is smaller than that. My understanding is that Titan is about half that size, so a quarter the size of the Earth. That would be sort of an approximation. I don't think I know offhand, but that's a pretty good estimate. Smaller than half the size of the Earth, but not much smaller. Sorry, that's not great, but that's what I got.
That's great. Well, it is 7:23, so if you are ready, we could start doing the prizes.
Oh, geez, absolutely.
Yes. All right. So what I'm going to do is start to share my screen. Get this ready here. So we have my students in my science methods class last week pulled together what they thought would be the best prizes for this particular presentation today. And so let me see here. Let me see if I can. I'm going to share my screen and we're going to find the prizes. Can you all see the prizes?
Are they the same as last night?
And I see a question saying, how do you participate in the raffle? And by being here, all 38 of you have an equal chance to win a prize that Anne has on her screen. So just by sticking around and hanging out with us tonight.
Yes. All right. Ready? Oh, there's some beautiful prizes too, guys. So the first prize is let me take this off of here. That's not right yet. A glow-in-the-dark solar system. And so looks like these are actual pieces. Like it'll be a 3D solar system. So that's pretty cool. Let's see here. So what Amanda will call out the name and we'll have 30 seconds. I'll set my timer. So anybody in your house, just if you have to go somewhere, just have somebody in your house respond. We just need to have your name and then you can text the host only, text your email address, and then we will get in touch with you when these arrive and how you will pick it up. So
don't not text, type in the chat.
Type in the chat. I'm sorry, yes.
No, it's okay. So we have our first winner, Gideon Bell. If you're here,
Okay.
you can send us a message that you're still here. Yep, we're here. Awesome. So that is our first one of the
Great.
night. And so the next thing you can do, and this will be the same speech for everybody, and if you were here yesterday, you'll also rehear this, keep sending in your email to the all panelists chat and we'll connect with you at another time.
Yes. All right. So our next one is a gravity maze for children 8 and up. So a gravity maze.
All right.
So, oh. who's the winner for that?
So the winner of this one is Rebecca Cantu, if I'm pronouncing that correctly.
Oh, that's wonderful. That's one of my students who helped with this.
Oh, good.
Is she still there? Becca, are you still there? Yes, yay. All right. She's there. She just raised her hand. So beautiful, a gravity maze. All right, our next one is a Curious Space Sim Family flashcard game. Explore, match, quiz, and spin through the universe.
All right, so the winner of this prize is Sanvi Avinash Gowda.
Oh boy.
Sanvi, if you are here and hanging out with us, yes, awesome.
Beautiful.
Wow, and these responses are coming in very
You
quickly.
guys are
You have a
great. Oh
very
my
engaged
goodness.
group.
Yes. Some good ones here. So Astro Kids Lab Constellation Telescope Simulator.
All right. So the number I drew, okay, we have Seth Felix
Okay, so Seth, let's see if Seth.
here.
All
3
right.
exclamation points.
Yes. All right. Our next one. Oh,
All right.
sorry, Chris. It's still on there. Astronaut Foods freeze-dried ice cream.
All right.
I remember as a child loving that. Sorry, Chris.
So the name that I'm seeing is Jennifer, no last name. But there's only one Jennifer with the first name.
Oh, and she raised her hand. All right. So Jennifer, be sure
Okay.
you get your full first name and last name and email to us. All right. Beautiful. And then we have here a solar system crystal ball, 3D.
All right. Randomly generate. Terry Carey. Terry, if you're here, let us know. Here, awesome.
All right. Is it T-E-R?
Yep, T-E-R-I.
Oh, T-E-R. Okay. All right. And then this is a very, very special one. And we've worked hard with the task force and everyone, but we're going to offer a personal tour of the observatory by Professor Christopher Duston. So you and your family will get to go up in the observatory as long as they have their vaccination cards. So to get on campus, you will have to have your vaccination card and a photo ID. I will work with you to get you and your family all set, and then we'll try to match schedules and sky to a good night, and you'll get a personal tour. And I can't tell you how amazing it is to be up there. I can't wait for it to open up to the public again in the spring. And so who is going to win this amazing trip?
So the name I generated was, I see Trisha. Trisha, I see also, maybe this will help distinguish. You wrote your name in all caps. So if you're still here, I saw a hand go up. I don't know if that was Trisha or not.
Oh, maybe chat in the thing, Trisha. Let's see. I can't see the.
Oh, no, she rose. Okay, we see the hand rose. So we're off that.
All right.
Yeah.
And then last but not, oh, we ready?
Yeah, I was just gonna say the same thing. You're probably sending the email.
Okay, perfect. And then last but not least, we have a free one-day pass to the Museum of Science for you and your family. And so we'll work with the Museum of Science and get you that pass. So
Okay.
who wins this grand prize?
So
Oh, the observatory, both are grand prizes.
the winner of this one is Pete.
Okay.
Is that a repeat? I don't think so.
No.
Let's see if Pete is
Here?
here. Awesome.
Oh,
Yes.
yay. Oh my goodness. This is great. And it's 7:30.
Well, we'll
So-
stay on so we can gather all the emails or phone
We'll
numbers.
gather all the emails, and then if there, oh, and also before I let you all know, we have other things though for everyone. We have other things. We have for you books that are related to space we'll be posting this on the website. So under tonight's presentation, these are the books that we chose that have won many awards for their so anyway, just incredible books about space for you and your family. So at least you can get the titles. And then we have resources around the Jupiter, Saturn, and tonight's presentation. So we have different resources that you could click on and explore to learn a little bit more about everything we talked about tonight. So I have 2 hands raised, and let's see if we have any more questions down here. Oh, these are all the here's.
Yeah.
Can you see the chat? So I will stop sharing. So all that will be posted on the website later this evening. And so, and somebody is, okay. This is for Jason. Thank you for sending that email. We'll get that, be sure. And actually, I think we were able to get it from the registration, but yes, we'll make sure that that's the one we have in our file for last night. Thank you for letting us know.
And Anne, I'm sorry if you've already said this, but this recording will be downloaded into an MP4 YouTube video. Did you already say this?
No.
It's not. Okay, great. And
Yeah.
I'm going to be posting that onto the Merrimack, Moon over Merrimack 2021 Google site. And so it should be up by tomorrow. So definitely check that out. You all should probably have access to that Google site. And if not, you can just look on it at the Merrimack Institute for New Teacher Support YouTube channel. So that's where it'll be under the Moon over Merrimack playlist. So that's how you can see it at another time.
And then thinking ahead to tomorrow night, we will have the Native American sovereignty, the Earth stories that bind us. And so that will be starting again tomorrow night at 6:30, and we will have resources and related books as well for that evening. We thank you all for being a part of this. Thank you, Professor Dustin. If anyone has any further questions and you want to stay on for just a few minutes, you're welcome to. But otherwise, have a beautiful evening, everyone, and we hope to see you tomorrow night. Thanks for coming tonight.
Good night.
Bye. Take care.